Hello my dear students, welcome to Dramatic Science. It's me, Ayan. Today is the second lecture of the topic machines. I hope you have gone through lecture 1. I will give the link of lecture 1 in the description. Kindly go through that at first, right? So let us see what will be our today's topics of discussion. So, as you can see, we have 6 topics in today's session. Number 1 is class 1 lever, number 2 class 2, class 3 lever, pulley system, definition and idea. Next, single fixed pulley and single movable pulley. So, this 6 will be our today's session, right? So, let us start with our first topic, that is class 1 lever. So now we have all the characteristics definitions of class 1 lever. So what is the definition? Class 1 lever are the types of lever where fulcrum, that is F, is in between effort and load. That means if we consider this as a class 1 lever, effort will be in this side, load will be in this side, and fulcrum, that is F, may be present in between E and L or any other position between them, right? Not necessary that F will be the middle point. Kindly note it down very sincerely. Okay, fulcrum will not be in a necessary condition to be present in the middle. मतलब middle में होगा ऐसा कोई condition नहीं है. The fulcrum should present in between effort and load. That's the concept, right? So here is the diagram. So this one is a bar. A is the position of effort, B is the position of fulcrum, C is the position of load. Then A to B, that is effort to fulcrum, is called effort arm, EA. Load to fulcrum is called load arm, that is BC, LA, right? So class 1 lever possesses some characteristics. Number 1, mechanical advantage at this kind of lever have values like 1 or greater than 1 or less than 1, anything. Second, velocity ratio, 1 greater than 1 or less than 1. Third point and important point, fulcrum F need not be at the midpoint between load and effort. Kindly please remember this, okay? Acha, number 4, load and effort must be in the same direction. You can see it. Like load is in downward direction and effort is also in downward direction, right? So they both will act in the same direction. So few examples are here: crowbar, pliers. At this kind of class 1 lever we get effort arm, that means this arm is greater than load arm, that is this arm, and mechanical advantage is greater than 1, and this type of instrument or machines are called force multiplier. Mechanical advantage जब 1 से ज़्यादा होगा, that is called force multiplier. I have discussed that in lecture 1. Kindly go through it. Lecture 1 is really important. Next, number 2, physical balance, where effort arm equals to load arm. I think you have seen physical balance in any grocery store, right? So effort arm equals to load arm, that's why mechanical advantage is 1 and it is not any kind of multiplier. Point number 3, example number 3, pair of scissors where effort arm is less than load arm and we get mechanical advantage velocity ratio as less than 1. So this type of instruments are used as speed multiplier, right? So this one is the concept of class 1 lever. Kindly note it down this in your classwork copy. Next we will move towards our second topic, that is class 2 lever. So now we have description about class 2 lever. So what is the definition? If fulcrum and effort are at the two ends of the lever and load is somewhere in between them, then that kind of levers are called class 2 lever. That means at the case of class 2 lever, load will be in the middle position. Not necessary in the middle position, but in between fulcrum and effort, right? So here is the diagram. In one side there is fulcrum, in another side there is no effort, load is in between them. So I haven't changed this to name. So A to B, that is fulcrum to effort, are effort arm EA, and load to fulcrum, that is BC LA, load arm, right? So characteristics number 1, mechanical advantage and velocity ratio both at the case of class 2 lever are greater than 1, because effort arm is greater than load arm. You can see it, like effort arm load arm se to bada hai, that's why mechanical advantage and velocity ratio both are greater than 1. Point number 3, load L need not be at the midpoint between F and E. F and E का middle point L ऐसा होगा, ये मतलब कोई necessary नहीं है. Point number 4, load and effort must be in the opposite direction. As you can see, effort in the upward sense and load is in the downward sense. So acting in the opposite direction. Examples: nutcracker, bottle opener, wheelbarrow. These all are the examples of class 2 lever. As class 2 lever act as force multiplier, that means small amount of effort we can get a force that will apply in a huge amount on the load. Like you are using a nutcracker, you are applying a small force, but the force applying on the load is greater than the force you applied, right? So that is the concept of force multiplier. So class 2 lever act as force multiplier. And that's all for the concept of class 2 lever. Now we will move towards class 3 lever. So for now we have the concept of class 3 lever. So what is the definition? If fulcrum, that is F, this one, and load, that is L, are at the two ends, this end and this end of the lever, and effort is somewhere in between them, effort is between F and L, then that kind of levers are called class 3 lever. So here is the diagram. As you can see, fulcrum and load are at two ends and effort is in between them. So A to B, that is effort to fulcrum, is effort arm, that is AB, and load to fulcrum, that is BC, is simply load arm. So here we can conclude that at the case of class 3 lever, load arm is greater than effort arm. Okay. Achha, so what are the characteristics? Mechanical advantage is less than 1, as because load arm is greater than effort arm, that's why MA and VR, that is velocity ratio, both are less than 1. Next, number 3, effort E need not to be at the midpoint between F and L, same as previous concept, मतलब E middle में होगा ऐसा कोई दरकार नहीं है. Second, fourth, load L and effort E, load L and effort E must be in the opposite direction. L is in this direction, E is in that direction, right? Okay, examples: sugar tongs, forearm knife, fishing rod, and these are used as speed multiplier. Let us take an example of forearm. Suppose I am lifting a load over here. So at the case of forearm, fulcrum is present here and load is here. So fulcrum and load are at two ends like this. And if you place a weight, you will feel the pressure or the force of that load on your wrist, right? So you are applying effort through wrist. Okay, so load is in one end, fulcrum is in one end, and effort you are putting through your wrist is in the in between these two, right? So forearm act as class 3 lever, right? So this is all about class 3 lever. Kindly note it down. Next we will move to our fourth concept, that is definition and description of pulley system. So now we have a simple definition of pulley system. A pulley is a kind of mechanical system where a wheel with a grooved rim around which a cord passes. A cord will pass through this, which acts to change the direction of force applied to the cord and is used to raise heavy weight. Like if we use a rope and here is a load, we can raise it. Next is a block system. A single or multiple pulleys fixed in a frame is called block system. Very simple definition. Tackle system, a rope or chain that winds the pulley in different blocks is called tackle system. So here are the types. Pulley are categorized in two types: fixed pulley, movable pulley. Fixed pulley, single fixed pulley, multiple fixed pulley. At the case of movable, single movable pulley, multiple movable pulley. Right? So for today's session, we have these two: single fixed pulley, single fixed pulley, single movable pulley. Right? A multiple, I will discuss that at lecture 3. Right? So that's all basic concept about pulley system. Let's start with our very interesting description about single fixed pulley system. So guys, we have the concept of single fixed pulley system. A pulley system having fixed axis of rotation is called single fixed pulley. Very simple definition, मतलब एक single axis of rotation होगा, that will be fixed, right? So this one is a schematic diagram. This one is the axle and this one is the pulley system. We can apply effort over here and it will carry, this pulley system will carry a load in the upward direction, and load will act, matlab L will act in the downward direction, but we can pull it in the upward direction. Like T and T are the tensions of the string. So here we need to calculate MA, mechanical advantage, velocity ratio and efficiency of this system. So effort equals to E, load equals to L, tension on the string is T. One thing you must remember, that tension always acts towards the center. This one is the center, so T towards the center, T towards the center. That's a fixed rule. So in balanced position, suppose you are applying effort, right, and you are balanced at a certain time, that means you are applying E and their load is acting, they both get same. That's why L equals to T, that means load equals to this tension, effort equal to this tension. So this says that load equals to effort, right? So load equals to effort, and this case is literally for ideal, which is not really, there is no ideal fixed pulley in our real world. But in practical life, we get effort is always greater than load, because we need to apply more effort to move a load, because some amount of effort get lost to in the friction of the pulley system. Okay. Acha. So mechanical advantage क्या होगा? Simply load by effort, that is L by E. L and E तो same है. That's why 1. This is also for ideal case. And if mechanical advantage is 1, then we say that there is no gain in mechanical advantage, right? मतलब single fixed pulley का mechanical advantage का कोई gain नहीं है. In actual case, mechanical advantage is less than 1 because effort तो बड़ा है. Effort is greater than load. That's why mechanical advantage is less than 1, right? अच्छा. Next, we are considering that effort moved a distance, suppose DE, and load moved a distance, suppose DL. Then velocity ratio equal to DE by DL. इसको मैंने lecture 1 में describe किया था कैसे आता है. So at the case of ideal machine, the distance traveled by effort equals to the distance traveled by load. That means DE and DL remain same, this one. So that's why velocity ratio is also 1. Okay. अच्छा. If we calculate efficiency, eta equals to formula क्या है? MA by VR. ये कैसे आया? ये भी lecture 1 में है. Efficiency equal to mechanical advantage by velocity ratio. Mechanical advantage का value क्या है? For ideal machine, ideal pulley system 1, velocity ratio 1, so 1 by 1, that is 1, that is 100%. And efficiency equals to 100% is practically unrealistic. So it's an ideal case, but in practical life we get efficiency that is eta less than 1 or 100%, right? So this one is the whole concept about single fixed pulley. Okay, next we will have our last topic of today's session, that is single movable pulley system. So now, as you can see, we have a interesting calculation of single movable pulley system. So what is the definition? A pulley system whose axis of rotation is not fixed in a position is called a single movable pulley system. That means, suppose this is the axis of rotation of a pulley system. This axis of rotation will also rotate with the pulley system. That's the difference. At the case of fixed pulley, this axis of rotation will be fixed and the pulley will move. But at the case of a single movable pulley system, this axis will also rotate, right? Acha. So calculation of mechanical advantage, velocity ratio and efficiency. At first, we are considering an ideal single movable pulley system. Okay. So this one is the diagram. This one is a rigid support, pulley system, axle, frame. Here is a load. You can see M, L. L is the load acting in the downward direction. So we need to give effort in the upward direction to pick the load, right? Acha. Here is a twist. Here, as you can see, T and T, that means tension on the string used to act in the upward direction. मैंने अभी जो सिंगल फिक्स पुली में कहा था कि टेंशन एक्ट्स टुवर्ड्स द सेंटर. रिमेंबर मी बाय माय फ्रेंड दैट दोज conditions, that means the direction of tension varies with the position or of the movement of the axis, right? Here the axis is moving, that's why T center की तरफ काम नहीं करेगा. If axis was fixed, then T and T will act towards the center. That's the concept. So E and T in the same direction and here T in the same direction. Acha. So we are applying effort over here and we want to move the load, this L, right? So for ideal system, number one, load L is balanced by the tension T in two segments of the string. ध्यान से देखो, इधर भी एक string है, इधर भी एक string है, T टेंशन है, T टेंशन है, T टेंशन और नीचे एक लोड L, मतलब L लोड को ये जो दो टेंशन T एंड T मैनेज करेगा. दैट्स वाई लोड इज बैलेंस्ड बाय द टेंशन T इन टू सेगमेंट्स ऑफ द स्ट्रिंग. नेक्स्ट द एफर्ट और T तो सिर्फ एक ही है. सो एफर्ट विल बी बैलेंस्ड बाय अ सिंगल टेंशन एट द फ्री एंड. Thus we can say load equals to this T plus this T. That's why 2T. And at the case of effort, E equals to T, right? So इधर से अगर T कैलकुलेट करेंगे तो क्या होगा? L/2. So E equals to L/2. That means effort equals to load by 2. That is the relation of effort and load at the case of single movable pulley. Okay. अच्छा, what is the mechanical advantage? Formula is load by effort. So effort is L/2, L cancel हो गया, 2 ऊपर चला गया. So mechanical advantage is 2 and eventually mechanical advantage is greater than 1. That means it's a force multiplier. Okay, देखो force multiplier. अच्छा, velocity ratio simply dE by dl. dE मतलब effort, 2d डिस्टेंस कवर किया, dl मतलब लोड ने d डिस्टेंस कवर किया, फिर dd कैंसिल हो गया, ये आ गया 2. अच्छा, d इक्वल टू डिस्टेंस रेज्ड बाय लोड, 2d इक्वल टू डिस्टेंस रेज्ड बाय एफर्ट. इसको ध्यान से समझो. ये जो एफर्ट है, एफर्ट अगर 2d डिस्टेंस कवर करेगा देन लोड विल कवर अ सिंगल डिस्टेंस, क्योंकि लोड को तो टी बैलेंस कर सकता है, लेकिन ये जो ई है इस ई को तो एक टी बैलेंस करेगा. दैट्स वाई एफर्ट का जो डिस्टेंस होगा वो ज़्यादा होगा, राइट? इसलिए एफर्ट अगर 2d डिस्टेंस कवर करता है देन लोड एल कवर्स अ सिंगल डिस्टेंस. दैट इज अ एक्सपेरिमेंटली प्रूवन फैक्ट, राइट? इफ एफर्ट कवर्स 2 मीटर देन लोड विल कवर 1 मीटर. दैट्स द कंसेप्ट. कवर्ड डिस्टेंस बाय एफर्ट 2d, कवर्ड डिस्टेंस बाय लोड इज सिंगल d. सो dd कैंसिल होकर सिंपली 2 हो गया, राइट? अच्छा, Efficiency, mechanical advantage by velocity ratio 2/2. This 2 by this 2, that is 1, that is 100%. As we have no considered ideal system पकड़ा है तो definitely तो efficiency 1 या 100% ही आएगा. That's obvious. Here we have a small thing for actual single movable pulley system, or you can say real world pulley system. Movable obviously. Mechanical advantage is less than 2. अच्छा, velocity ratio is 2 and efficiency is less than 1. This is so true, that's fine. अच्छा, mechanical advantage is less than 2 मतलब definitely we need to apply more effort to move the load. मतलब E तो ज़्यादा होना चाहिए, E ज़्यादा होगा, L कम होगा. That's why MA will decrease below 2. 2 से कम हो जाएगा. ठीक है. अच्छा, नेक्स्ट वेलोसिटी रेशियो विल बी 2. वेलोसिटी रेशियो 2 मेंटेन होगा. क्यों? सिंपल, एफर्ट तो मतलब 2d डिस्टेंस उसको जाना ही होगा टू मूव L बाई 1 मीटर. ये तो वेलोसिटी रेशियो तो सिंपल डिस्टेंस के साथ रिलेटेड है. दैट्स वाई एफर्ट को तो उतना डिस्टेंस ट्रेवल करना ही होगा टू मूव लोड बाई दैट डिस्टेंस. राइट, एफर्ट को 2 मीटर आइडियल केस में और एक्चुअल केस में दोनों ही केस में ट्रैवल करना है सो दैट लोड कैन मूव टू 1 मीटर. सिंपल. अच्छा, सो दिस वन इज फॉर एक्चुअल कंसेप्ट. तो ये काइंडली अपने कॉपी में फटाफट से नोट डाउन कर लो और या फिर स्क्रीनशॉट लेके कर लो कॉपी में. So guys, that's all from today's session. I hope you have gained knowledge from all these 6 topics, and in lecture 3 I will discuss several cases about multiple pulley system, block and tackle system, and very interesting numericals related to machines, right? So if this video helps, gives a thumbs up, do subscribe, and if you feel any doubt you can comment or you can message me in the Instagram also. तो बस चलते हैं आज के लिए, मिलेंगे लेक्चर 3 में. तब तक नमस्कार, टाटा, बाय बाय.